All right, so this is a little bit of a taste as to what we're going to learn about in section 2 over why do we care about this. As always, this allows us to solve differential equations in new and interesting ways and or gives us access to new patterns we have not seen before. So let's start with, we got y equal summation of n equals 0 of c sub n x to the n. And so what would y prime look like? So that was something we talked about earlier about the derivative of a power series. So that's going to start at n equals 1 to infinity. That's c sub n times n to the x to the n minus 1 for that. And then let's put them together. So in that differential equation we have y prime plus y. So that would be n equals 0 to infinity of c sub n of x to the n plus summation n equals 1 to infinity of c sub n of n times x to the n minus 1. And hopefully this looks a little familiar. What do we do next? Okay, so now we want to do an indices shift. So this first part, I'm going to let k equals n. And the second part, I'm going to let k equals n minus 1. So just a reminder then, that means n equals k plus 1. And then I'm going to rewrite this. Let me give myself a little space. So that would be summation of k equals 0 to infinity of c sub k of x to the k. And then this other one would be summation, let's see, if I put n equals 1 and I get k equals 0, so that's good. Got those two to match to infinity. And then this is c to the k plus 1 times n, and n is k plus 1, x to the k. Oh, that's good. That's good news. So we got we got our summations to match, we got our exponents to match, so we can combine them into a single expression. So k equals 0 to infinity, and we got c of k plus c of k plus 1 times k plus 1, all of which is times x to the k power. Okay, so as a reminder, this entire expression was equal to 0. So what does that tell us has to equal 0? And that's this inside piece. So c sub k plus c sub k plus 1 times k plus 1. Those terms have to be 0. Okay, so I can then rewrite this in terms of, say c to the k plus 1. So c to the k plus 1 would be negative 1 over k plus 1, the c sub k. And we're going to do some substituting here in a second. So k itself, we're saying, starts at 0, and then 1, and then 2, and then 3, and then dot, dot, dot. So now I'm going to do a little bit of expanding here. So what would, say, the first term look like? So c sub 1. So c sub 1 would be negative 1 over, let's see, k would have to be 0 at that point. So 1 c naught, so that's negative c naught. What would c2 look like? So that would be negative 1 half c1, which is negative 1 half negative C0. So that's just 1/2 C0. C3 would be negative 1/3 C2, which is negative 1/3 1/2 C0, which is negative 1/3 times 2 C0, or negative 1/6 C0. We're going to try to recognize a pattern here, so maybe keeping it in factored form might be the better choice. Let's do one more, why not? C sub 4 is negative 1/4 C3, which is negative 1/4 times 1/3 times 2 C0. Hopefully you go, wait a second, that's a factorial. So that's a positive 1/4 times 3 times 2 C0, and so on. Okay, so using our original assumed solution and the results we found, then y would look like C0 plus C sub 1x plus C sub 2x squared plus C sub 3x cubed plus the fourth term. However, we also know that we can rewrite these things all in terms of that same initial constant. So if I go back and make that substitution, then I get C0 minus C sub 0 of x plus 1/2 C sub 0 of x squared minus 1/3 times 2 C sub 0 x cubed plus 1/4 times 3 times 2 C sub 0 of x to the fourth. And I can essentially factor out all of those lovely terms there, that C sub 0, so I'll have that constant on it, which gives me a general expansion of 1 minus x plus 1/2 x squared minus 1/3 times 2 x cubed plus 1/4 times 3 times 2 x to the fourth plus dot dot dot. And now the question is, can I generalize this? Because now I've got a very clearly defined pattern of this. So going back into our summation form here, I can start at 0, go up to infinity. I have an alternating term, so it's alternating between positive, negative, positive, negative. So that's either negative 1 to the k or negative 1 to the k plus 1. So we play around with which is going to give me the correct plus minus plus minus. So that's k. Then we have x to the k. And what do we notice is going on with each and every position? As I create another term there, we're looking at some form of factorial. So k factorial in that one.